So let's talk about displaying data. Here I have some information about bicycle helmet use in Mississauga. And there are 5 different categories. People that always wear helmets, people that wear most of the time, rarely, never, and then people that didn't answer the survey. So we have these 5 different categories, and we want to display the information in a chart that helps people understand the information better. So we're going to create a chart, and we have several options here in Google Sheets. We have line graphs that we could use. Actually, before I do that, I'm going to select this. And so we could use a pie chart. We could have a bar graph. Could have a line graph. Which of these makes sense? So if we consider the circle graph, it might not be the best choice because we have this category where people have not answered, and so it's not really part of the total picture, because all these people that didn't answer the survey, they fit into one of these categories. They just haven't answered it. So I would say that maybe a circle graph is probably not the best choice. If we tried to use a line graph, it doesn't really make a whole lot of sense because these are not numbers, they're not changing, they're just different categories. And so the graph that probably makes the most sense would be a bar chart or the other very similar column chart, so that we can see all the different categories and we can see how big they are relative to each other. We can see that people that the group of people that never use a helmet is much, much bigger than the people that just use it rarely. Here's some data on how people commute each day, and it's expressed in percentages. So they asked a bunch of people, and they fell into one of these categories. You can only really fall into one of these categories. You either drive or you carpool, you take transit, you walk or cycle, or some other category. They've lumped it all together. So if we make a graph out of this, again, would we use a column chart? Does that really help us? Would we use a line graph? Doesn't really make any sense because this isn't like a spectrum of commuting modes. They don't have numbers attached to them. It doesn't make sense to use a line graph because it doesn't tell us anything interesting. Probably the best choice would be to use a circle graph because these are all parts of a whole. So the whole population, how many fit into the driving. So this graph makes it really clear that by far most people use their car to drive to work, and they drive by themselves, not carpooling. Here's some information about temperatures over time. And so we have a date and we have a daily temperature. If we wanted to make this information more visible, would we use a line graph? Would we use a column chart? Would we use a pie chart? Pie chart doesn't really make a whole lot of sense, does it? So if we use a line graph, we can kind of see change and over time, and because the x-axis is a date, we can see temperature rising and falling, and so this is a good choice for this type of data. Here's some information about how long people sleep. So you could imagine that a survey was taken, and they asked 51 people, how many hours per night do you sleep? And this person here sleeps 5.4 hours. So if we took all that data, what could we do with it that makes it more easy to understand and interpret? So if we make a chart, here we've got a histogram. A line graph doesn't make a whole lot of sense. These are just randomly ordered sleeping times of people. They're not in any particular order, so looking at them in a line graph doesn't make any sense. If you try to make a circle graph out of it, that doesn't make any sense either. What we're actually looking for is a histogram. And what the histogram does is it groups different ranges of sleeping into a small number of categories. There's a large number of different sleeping lengths. Because it's a decimal, there's so many different possibilities. We wouldn't want to make a category for each one of those individual numbers. Instead, what we want to do is make what Google calls a bucket. Okay, so we could make the bucket size 2 hours. So this bar right here represents all the people who sleep from 3 hours to up until just below 5 hours. And these are all the people who sleep 5 or more hours, but less than 7 hours. So we can change the bucket size here to a single hour, and it's a little bit more descriptive. Right? So we can see that from this graph, a lot of people get between 5 and 6 hours. Several people get between 6 and 7. A lot of people are sleeping 3 to 4 hours, which seems really weird. And then very few people are sleeping between 4 and 5 hours. And so the histogram makes it really clear what the most popular sleeping amount of time is. So that helps us that way. So let's go back and take a look at the data we were using to create these graphs. So in this case, when we polled the people, we didn't ask them how many hours per day they wear a helmet or how many days of the year they wear a helmet. We asked them, do you wear it always? Do you wear it most of the time? Do you wear it rarely? Never? These are not numbers. These are categories. So we call this categorical data. With commuting, it's the same thing. You fall into one of these categories. Driving and carpooling is not a quantity. They're just categories. So you fall into one category or the other. So this, again, is categorical data. With temperatures, we are dealing with numbers. The temperature is a number. We can think of the date as a number as well, because we can put them in sequence and in order. So this is numerical data. We're not putting temperatures into categories. Sleeping amount. This is also numeric data, because how much you sleep is expressed as a decimal number. So we can separate data into two sort of situations. Either it is numeric or it is categorical. Numeric data is data that can be expressed using numbers. So examples are dollar amounts, distance,
Categorical data is data that are types rather than numbers, so colors or seasons of the year. So taking a look at the numeric example, so we said temperature and sleeping are both numeric. Temperature, we say, is continuous because the temperature can be anything between 9 degrees and 13 degrees. There's an infinite number of possibilities because we could have like 9.345 degrees Celsius or 11.205 degrees Celsius. There's an infinite number of possibilities. So that we call this continuous data. Continuous data. So same thing with sleeping, because we're measuring a quantity of time. Time is continuous because it can be any sort of value between 3 and 10 hours, if that's what the range is. Discrete data, on the other hand, is data that you can't subdivide it. There's only a certain number of possible values. So data is either continuous or discrete. Continuous data can have an infinite number of possible values. So when you're talking about the mass of an apple or an average temperature, those are continuous data because the numbers have an infinite number of possible values. Discrete data is data that can have a limited number of possible values. So number of siblings, number of holidays. You can't have 2.7 siblings. You either have 0 or 1 or 2 or 3 or 4. That's discrete data. So when do we use a circle graph? Well, it's hard to come up with a very simplistic answer to that question, but we can talk about what circle graphs are good at. Circle graphs show values as a portion of a whole. So if it makes sense to add up all the values together, then maybe it makes sense to use a graph. So for example, this is someone's budget, and their whole budget is all the money they've spent. And this is the money that they've spent broken into categories. So it makes sense to put this into a circle graph to see how much money you're spending on different things. In this line graph here, we're looking at how the cookie sales of a Girl Scout sales person is going throughout the week and how it's changing. The strength here is that it shows how values change over time or some other similar variable. Maybe it's not time, maybe it's distance or something like that. When do we use a bar graph? Well, a bar graph is probably you're going to use a bar graph if you couldn't use a circle graph or a line graph and you just have things in categories. Here we have a graph of a campground and what days of the week are popular for reservations. So on Monday of some time period, they only had 5 reservations, but Friday and Saturday were very popular. It doesn't make sense to make a line graph out of this because we're not talking about 1 week, we're talking about many weeks by the looks of these numbers, and we're just sort of finding out which of the days is the most popular. So a bar graph makes sense in this case. And so again, we're talking about categories. Okay, so histograms are good when you have many possible values, and you need to put them into ranges so that you can understand the data better. So if your data is continuous, probably a histogram is a good choice. If you want to break
that data into ranges. Here they broke it into half centimeter groupings. And so the data doesn't necessarily have to be decimal values. They could be integers, but maybe it goes from like 3 to 5,000 or something, and you don't want 5,000 ticks on your graph, so you group it into bigger buckets.